My name is Martin Oreo, and I'm the Business Development Manager for Water Energy. Our family business has been doing nothing but geothermal for about 38 years now. What we are really, the industry refers to as a value-added distributor. We do sell the heat pump systems, the geothermal heat pump systems, to the installing contractor community for resale. But we also provide end-to-end design support for that service. The reality is that a properly installed geothermal system depends more on what I do with my delivery and my earth extraction than the box itself. Because with a geothermal heat pump, people say, I get it, you bring in the water at 50 degrees and you heat it up to 70, right? Actually, no. What we do is we bring in that 50-degree water or that 35-degree loop fluid and we extract heat out of it. Hard to wrap your head around that, but there's energy in any mass that is above minus 273 degrees. So the further away from where I want to be, the more energy I have to use. So we'll look at an air source heat pump. It's 0 outside, I want my house to be 70. That's a 70-degree trip. Well, it's 0 outside and I want my house to be 70, it's 50 underground. That's a 20-degree trip. Really just talking about a heat exchanger. So when we talk about that exchange, we want to manage the deltas of temperature and pressure on both sides of that box to be the most advantageous, to be what we'll call a sweet spot for the refrigerant circuit to make that energy transfer in the most advantageous way, using the least amount of energy to run that well pump, compressor, and delivery pump, whether fan or circulator. So those three electric elements are not heaters by any stretch of the imagination, but working together, they are extracting that free solar energy out of the ground. They're storing that unwanted solar gain back in the ground. So every mechanical device has frictions and encumbrances that make it less efficient. So when we design the system, we want to make sure we get just the right amount of fluid at just the right pressure to be the optimum earth exchange temperature on the earth side, and then let it breathe easy on the delivery. So again, as I depart from that, I put in ductwork that's a little smaller than it really should be, I don't do my makeup air systems properly, and I increase the pressure in that ductwork. Well, now getting the heat off of that refrigerant coil with the airstream, I'm going to use more fan energy, and I'm going to have less comfortable delivery off of that coil. If I don't let it operate in that ideal space where it's moving around the refrigerant from a gas to a solid back to a gas to move the energy, then I pay for that in inefficiency. And not only that, in longevity. Think of the refrigerator. If I keep the cat hair vacuumed off the coil of the refrigerator, it's going to last 30 years. If I choke it off or I don't let the air flow across that refrigerant coil, I'm going to burn it out. Exactly the same thing is true with the geothermal heat.